Hey, my name is Jonathan Helm, and in this video, I'll show you how to calculate some measures of central tendency in R. So for this video, I'm just going to use the salary data set, and that's available on my website in case you want to use it. If you have your own data set that you want to calculate descriptive statistics for, then I suggest you just use that one and follow along with the video. So I'll go ahead and I'll open up R. I'm going to open up a new editor inside of R. And the first thing I'll do is read in the dataset. And I'll use the read.csv function for this one. I'll right click my CSV function, my CSV dataset. I'll hit get info. I'm going to copy the path. And I will add the name of the dataset to the end of that path. I'll take a look at the first 6 rows. I'm going to open up the dataset just to take a peek. Remember, it's always best practice to double check that what you see in your data file matches what you see in R. Right, so I'm looking at ID, those values look the same. I'm looking at salary, those values look the same. Number of pubs looks the same. Years on the job, those values look the same. Okay, so remember, you always want to double check just to make sure it's, you don't want to run into the problem of if you read it incorrectly somehow that you've then gone and calculated several statistics and now you can't use those anymore. And so just double check. So let's talk about measures of central tendency. Really, so I'm just going to talk about mean and median today because I think those are the most commonly used ones. There are functions to calculate the mode, but they're a little more complicated for continuous variables, so I won't dive into that one unless I get some comments from you all about making that one. And if you want to learn how to calculate mode, then I'll show you how to do that. So for this one, let's say I have my data set in R, and I'm looking at salary or number of pubs, and I just think, like, I just want to calculate the means of these variables. Well, what I can do is use, not surprisingly, the mean function. Okay, so I have mean, open paren, then I need to insert an object inside that function. And one of the easiest ways to do it is to just to call upon the salary variable, right? So I'll say data $salary. This is one way to call upon it. Now, of course, if I run this, actually I think in this situation, okay, I'm going to get back the mean, right? So what this is saying is that in my data set, the mean is $76,000 a year, right? And so this is the average salary for all the professors that are in my sample. Now, one thing that I didn't include in this code was an option for missingness, so I can also add in na.rm equals true. And what this means is that if you run into a missing value, that it'll just remove that and not use that as part of the mean calculation. In this particular situation, the dataset doesn't contain any missingness for salary, so I won't run into that issue. And that's why if I even include that option, I'm going to reproduce the exact same value because there aren't any missing values in salary. Now for number of publications, on the other hand, I believe that one does have some missing values embedded in it. So number of pubs, right, if I highlight and run that, you'll see that it's going to give you back this NA, right? It says not available. And what R is telling you is that if I calculate the mean using a missing value somewhere in here, then of course I can't calculate that mean because I don't know what it would be, right? Maybe the person who had a missing value made $200,000 a year. Maybe they made $10,000 a year. Maybe they made 80, but because I don't know that, I actually don't know the mean, right? So the way that we get around this is by adding in that na.rm equals true, okay? So if I highlight and run that, right, then I'm going to get back that the average number of publications per year was about 3.5 for individuals that are in my sample. Okay, so this is a really easy way to calculate means. Importantly, you can only calculate means on numeric variables, right? So I should be able to apply the mean function to ID, salary, number of publication, years grants, so on, but I shouldn't be able to do it with gender. However, I will be able to do it with female, right? Because the variable female, which is just that 0, 1 indicator, let's just go ahead and do it. Do mean of data, $female, let's see what we get. That's it. I don't have any missing values on that one either, right? And it looks like about 50-50, right? So the average indicates the proportion of individuals that would be male. Do that the right way. Yeah, the proportion, I think, is zeros. I have ones. average all those. So yeah, the higher, yeah, so this is the proportion of individuals that are female. So in this case, about 48% are female. So really, but the bigger picture is that I can calculate this for numeric values, but if I tried to enter within gender, right, so if I do mean data gender, I get an A. I also get a warning, so let me just remove. I still get this NA back, right? And really what this is telling me is that, see, the argument is not numeric or logical, right? So by logical, they're true and false values, which we haven't really talked about yet, and you don't need to worry. But really what R is trying to tell you is I can't calculate a mean for a variable that just contains a categorical indicator, right? So I'm not able to calculate that mean for you. So if you want to use means or medians or things like that, then we'll need to use a different form of that variable. And so just be aware of that. Okay, so that's the mean. I don't think it's really shocking to anyone to find out that if we wanted to do median, right, it's just using the median function. So if I do median data salary, oops. Right, this is the median value, right, which we can see is actually different from the mean of 76,000 up here. It's the median value is about 74,000 a year. Okay, and if we move on to number of publications, we're going to run into the same problem. So median for data $, number of pubs. It should give us back an NA, right? And again, that's because we have missingness in it. So I do NA.rm is equal to true. Right, we see the median value is about 3.48. Now, one thing that I want you to know about these true and false statements here, whenever you're typing NA.rm equals true, you need to make sure that true is all capitals, right? True is all capitals. Sometimes we'll write false for other situations, not in this one. And if that is if in that situation you use false, you need to make sure that false is in all capitals as well. Okay, so true in all capitals means a specific thing in R, right? And that's why we need to have all of those be capital letters. Okay, now let's say that you want to calculate the means across multiple variables. Right, and this is most often the case. It's rare, but you know, sometimes you want to just calculate the mean for one variable. But looking at the top of our data really quickly, maybe I want to calculate the mean for salary, number of publications, years on the job, grants. Okay, so I want to do it for all of my numerical variables. Right, remember that we can call on those. So if I use square brackets and a vector, I can do salary, number of pubs, years on job, and grants. And what this is saying to R, just this part here, is it's saying I want to extract out the data, right, for these 4 columns, right? So remember I have an empty space here, which indicates I want all of the rows, right? I want all of the rows, and I'm just going to extract out these columns. What I can do is I can drop this into what we call an apply function. Okay. So apply means I'm going to apply a function across different subsets of data, right? So the first argument, we can even write capital X equals this, right? And that's indicating to R that this is the data set that we're going to apply the function on. We have this second argument called margin in capital letters. You can set this equal to 2 or to 1 or to both, right? So 1 indicates that we're going to move through the rows of the data set and apply the function for the rows. And the column, number 2 means across the columns, right? So I'm going to apply a single function across each of the columns. So in this situation, I want to calculate the mean of salary, number of publications, years on the job, and grants, right? So I'm moving across the columns. So I'm going to set margin is equal to 2. If I wanted to do rows, it would be margin is equal to 1. And fun is our function, and that can just be equal to mean. And then I'm going to add in one more, which is na.rm is equal to true. And what that means is that we're going to remove any missingness from the variable before we calculate that mean. Notice that when we have the fun function here, right, we're typing mean, but we're not including the parentheses. So you don't need to include that part. You just write the name of the function, right? And so R will call on it from there. So if I highlight and run all of this code, right, you'll see that it's going to spit back the means of each of those variables, right? So that way I can calculate the mean across the columns for each one. And so this is the mean of salary, this is the mean of number of publications, the mean for years on the job, and the mean number of grants. Okay. So in a similar way, I'm just going to copy and paste this code if I wanted to do a different function, right, let's say instead of mean I wanted to do median, I could type that in here. Again, I'm going to keep the na.rmes equal to true. So if I highlight and run that, right now it's going to calculate medians for each one. Okay. So this is a really easy way to calculate kind of measures of central tendency for your data set. I suggest using means or medians. I just one quick one that I want to share. This is probably the more common one. I feel like this function became popular after I learned apply statements several years ago. So there's one called the call means function. Right, and this is basically a wrapper function for the apply statement. So if I do call means, the only thing I need to put in there is the name of the part of the data set that I want to calculate means for. So if I use this function called call means, now the only input that I need is the variables that I want to actually calculate column means on. I think I also need an na.rn is equal to true. So if I highlight and run that, right, it's going to give me the means for each of these columns in the same way that the apply statement did. The only thing is that call means is specific to just calculating means. So I tend to like using the apply statement because it's a little more generic. I can use any function that I want inside, right? I can use mean or I can use median. Whereas if I need to calculate something really quickly, I might use the call means function instead just because it's a little faster to code up. Okay. Thanks for watching this video. If you liked it, please like it. If you haven't subscribed to my channel yet, please subscribe. If you have any comments or questions, feel free to leave them below in the comment section, or you can also email me directly at jonathanleehelm@gmail.com. Feel free to follow me on Twitter at jonathanleehelm, and I look forward to hearing any feedback that you have. Thank you so much.